Hello everyone, today we're going to do something called the Buffon's needle experiment. So here I have a piece of paper with 5 lines that are separated by the same distance. And here I have some needles. And this is how the experiment works. The distance between consecutive lines is equal to twice the length of a single needle, as you can see here. And I'm going to randomly drop these needles onto the paper like this. I'm just going to randomly toss these needles around the paper. And now I'm going to count how many needles I dropped in total. So in this case, it's 10. And then I'm going to count how many of them cross this line. So in this case, it's 1, 2, 2, and 3. All right, now, so if we divide the total number of needles by the number of needles that crosses the lines, we get 10 divided by 3, which is about 3.33. Now, this is only a really small sample. If we do a really large sample, we will get an approximate value for pi. So to see why this experiment outputs pi, I have a really simple and easy proof here. So here's the proof. So let's say here are the 2 lines that the pins are dropped in. And let's imagine there is a needle right here. And let's let the length of this needle be 1. So this length will be 2. And let's imagine that this needle is projected onto a line that is perpendicular to the vertical lines. Let's say this line, and this is 90 degrees. And when we project this line onto this line, we get this part. And then let's imagine this is angle theta. So we have a triangle right here. And if this is 1, this will be cosine theta. Now we have the probability of the needle crossing the line equals like the average of all the probabilities that the projection is crossing the line. And this, of course, equals to the probability of the average projection. Crossing the line. Now, the hard thing about this is that we need to find the average length of the projection. But fortunately, there is a trick. So let's imagine this graph. So this is y equals cosine x, and let's say this is pi. No, this is pi over 2. And actually, these are all the projection lengths because this is cosine theta. And this area is the sum of all the projection lengths. And we need to find the average. But let's imagine this. What if this part right here is being squished into this shape? And since this length is pi over 2, and let's also say this length is pi over 2. And let's also say that this area, the area of this rectangle, equals the area of this part. So since these areas are all the same and the bottom lengths are all the same, this length will be the average of all the projections, logically. Now, by calculus, we can find that the area of this part is 1. So the area of this part equals 1. Now we can do a small calculation. If this is 1 and 1 divided by pi divided by 2 is 2 divided by pi. Now we could think about this. Let's go back to these two lines again. For example, this is the projection average length. Well, it's not to scale actually, but we'll do something like that. So this is the projection, and we only need to consider what's the probability of the average projection, which is this, crossing the line. And in this case, we only need to consider this in one dimension because it's a line. And let's say these are all the possible outcomes of the projection. I'll move to here. And since this is a line, we must specify a reference point. So let's say this point is the reference point for the whole projection. And we have these dots right here. Now, when the dot is in this part, the projection crosses the line. And when the dot is in this part, the projection doesn't cross the line. And since this whole thing is 2, and this part right here, the length of this part is 2 divided by pi, which we have calculated earlier. The total number of random needle tosses divided by the number of needles that do cross the line. So this equals the region between the lines, which is this part, which is 2, divided by the region of crossing the line. So since this is this part, which is 2, it is 2 divided by the region of crossing the line, which is the length of the projection, which is we have calculated earlier, 2 divided by pi. And this outputs pi. So there we are with our answer. So this is a really simple proof to why this experiment outputs pi, which only needs a really fundamental basis of calculus. And thank you for watching.